Hey class, in today's lesson we're going to talk about rational functions and their graphs, which is found in section 8-3, part 2 of your book. Our objective is to graph rational functions. So the first characteristic that we want to talk about our graphs is vertical asymptotes. So we kind of briefly touched on vertical asymptotes when we were talking about translations when it was of a certain form, right? So when we were of the form y equals 1 or I should say a, over x minus h plus k. Remember h, when it was in this format, would be our vertical asymptote. Well, now we're going to get it to where we have polynomial functions, p of x and q of x, that we'll need to simplify. And basically, to find the vertical asymptotes, we will have to set our denominator equal to 0. Okay, so we're going to set our denominator equal to 0 to find asymptotes, or vertical asymptotes. So here we go. In our first example, it says, what are the vertical asymptotes for the graph of the equation below? Well, here's the deal. We don't have anything to cancel out, meaning they don't have any common factors. So we'll just set our denominator equal to 0, which is very simple, guys. In other words, I can just say equal to 0. So x minus 2, in fact, I don't even need the parentheses. X minus 2 equal to 0, x minus 3 equal to 0. So x must equal 2 and 3 as our vertical asymptotes. Alright, that's it. Very simple. Alright, so let's try the next one. Again, find the vertical asymptotes. If I just set those equal to 0, I'll have x equal to 1 and negative 3. Alright, so the next type of asymptote that we want to find is horizontal asymptotes. And once again, when we had it, when we were talking about translations, right, we had y equals a over x minus h plus k. K, in that case, was our horizontal asymptote, right? But now, obviously, once again, because they are polynomial functions, they'll be a little different. So it's really going to be based off of the power, the degree of your numerator and your denominator. So what this is saying is that when it is less than, so less is 0, okay, greater, and this is numerator versus denominator, by the way. So greater is none. And then equal is the coefficient of a over b. So your coefficients. So your leading terms coefficients. That would be your horizontal asymptote. Okay, so we are going to try do our example. Okay, and the first example, okay, we need to identify our degrees. So our first degree is 1, our second degree, or our denominator's degree, is 1. So they are equal, right? And so when they were equal, it was supposed to be the coefficient of the first term over the second. So the coefficient of the first is 2 over the coefficient of the bottom one. Well, the coefficient of x is 1. So our horizontal asymptote is y equals 2. All right, let's try the next one. So again, we're looking at our degrees. So the first degree is 1, the second degree is 2. So less than, do we remember? Less than is 0. So our horizontal asymptote is y equals 0. Now, the less than and the greater than, honestly, are the ones that are the most difficult to remember. So however you need to come up with some type of wording to make sure that you know that less than is 0 and greater than is none, then you'll be fine. Okay, so let's do the last. Alright, so again, our degree here is 2 and the bottom degree is 1, so this is greater than. And remember what I just said, greater than is none. So our horizontal asymptote here is none. Okay, we're going to practice with our tries. All right, so the first one again, 1 and 1, right? They're the same power. So since they're equal, then you have to do A over B, which is -2 over 1. So our horizontal asymptote is y equal to -2. Okay, the next one, we have 1 and then we have 2. So that's less than, and less than is a horizontal asymptote of y equals 0. Okay, 2 over 1, that's obviously greater than. So that horizontal asymptote is none. There isn't one. All right, in example 4, it says, what are the x and y intercepts and the horizontal and vertical asymptotes of the function below, then sketch. So here's the deal. This is going to have a lot of information, so what we're going to do is we're going to sketch as we find information. So actually, instead of finding the x and y intercepts first, I'm going to find the asymptotes first, since we just finished learning about those. All right, now before we do anything, what we really need to do, while this is still kind of in standard form, the easiest one to find is our horizontal asymptote. All right, because the horizontal asymptote is all about the degrees. So the degree of the first one is 2, and then of the bottom is 2 also, so that's equal. So we need to take their coefficients. So there's a 1 and a 1. So 1 divided by 1 gives us a horizontal asymptote of y equal to 1. So I'm going to go ahead and put y equal to 1 on our graph. Okay? Then the next one, to find our vertical asymptote, we have to actually factor that out. So going back to our factoring days, right? What factors of -12 will give you 1? It should be 3 and 4, and specifically it should be +4 and -3. So our numerator will be x plus 4, x minus 3, and for the denominator, that's difference of squares, so that's x plus 2 and x minus 2. That's an x. Okay, so when you find vertical asymptote, we have to check. So we factored. There are no common factors as far as the numerator and the denominator are concerned. So our vertical asymptotes would be setting the denominator equal to 0. So our vertical asymptotes are going to be x equals plus or minus 2, or plus and minus 2 this time. So here's -2. And there's +2. All right, now from there, to find our intercepts, right? We've learned this, or we've known this since the beginning of the year. To find the x-intercept, you need to make y0. To find the y-intercept, you need to make x0, right? So let's start with the y-intercept. To be able to find the y-intercept, right? That means we are, did I say y or x? I don't remember what I just said. Oh well. So to be able to find the y-intercept, we need to make all of our x's 0. So I'm going to deal with it actually in the standard form here, because it's a lot easier to see. It's pretty obvious. Once you make those x's 0, really you're left with -12 over -4. Which is going to give you 3. So our y-intercept is actually 0, 3, and that's the only y-intercept that we have. So I'm going to plot that point on our graph up here. Okay, and then to find the x-intercepts, we need to make y0. So to make y0 here, really we don't care about the denominator, right? Because if we make y0, and I'll show you, if we make y0, and now I'm going to use the factored form. It wouldn't matter which one I chose, but I'll go ahead and use the factored form on this one. If I make y0 right, I would have to multiply both sides by the denominator, which would still make it 0. So really the denominator is gone. And if I set those equal to 0, then the x-intercepts would be -4 and +3. So as ordered pairs, that would be not 0, -4. That would be -4, 0, and 3, 0. So -4, 1, 2, 3, 4, 0. There's one of them. And the other one is 3, 0. So 1, 2, 3. And there's another one. Now, here's the deal. We don't have enough information to really sketch from here. Like, I'm a teacher and I can kind of tell you what I know is going to happen. But honestly, you guys need to be able to see for yourselves. Okay, so we're going to just do a couple more points just to prove that this sketch is going to have this certain shape. And then after that, you can kind of get a general idea of how these reciprocal functions will kind of look. So I'm going to erase this bottom information so that I can create a table. Alright, so we want just a little bit more information from our table other than what's already given to us. So the farthest we went out was -4 as our x value. Right? So let's do -3. There's no point in doing -2 because that's a vertical asymptote. Right? So we can do -1, we can do 0, we can do 1. Once again, there's no point of doing 2. We've already got 3, so let's go ahead and also do 4. Okay? So when I substitute in -3 for x, and what I would obviously be doing is -3 in for x for the factored form, right? I'll do these one at a time. So the first factor, -3 plus 4, would be 1 times -3 minus 3 would be -6. Over -3 plus 2 is -1 times -3 minus 2 is -5. So this would become -6 over 5, and so we're going to get a fraction -6/5, which is a little over -1, right? So that first point, -3, and then -1 and 1/5 really is just a little bit down here. It's right about there. Okay, and then the next one, -1. If I substitute in -1, -1 plus 4 is 3. -1 minus 3 is -4. Over -1 plus 2 is 1, and -1 minus 2 is -3. So that's going to give us -12 over -3, which we know is 4. So -1, 4 is the point there. So -1, +1, 2, 3, 4 is about here. Let's keep going. 0, very simple, right? Very nice for us. 0 is actually already done, right? I forgot about that one. That was our y-intercept, so that was 3. The next one, if I substitute in 1, 1 plus 4 is 5, 1 minus 3 is -2. The denominator, 1 plus 2 is 3, 1 minus 2 is -1, so that's going to give us -10 over -3. And there's no reducing there, but that's really about 3 and 1/3. So 3 and 1/3. So for the 1, it's about 3 and 1/3, so a little bit about here. No, that's not right. Alright, and then the last one, 4, I'm just going to go ahead and skip through all the math and just go ahead and tell you that the answer is going to be 2/3. So close to 1 almost 1, so about here. So when I graph this new one, I mean now with our extra points, we can obviously see that our graph is going to do something of this nature. And now we are done. So now that you can see what a general shape might do, now that you have your intercepts on here, now that you can see what it's going to do, you may not need to do the additional points just to create a sketch. But until you are definitely sure about the direction that your graph is going to take you, for example, if you don't have, let's say we didn't have an intercept over here, you may not have automatically known what it was going to do. Be sure to create a table if you need to. All right, so let's do the next one. All right, so what are the x and y intercepts? What are the horizontal and vertical asymptotes? Okay, so again, we're going to start with our graph. All right, and let's start with our horizontal asymptote, which remember our horizontal asymptote is the numerator's power over the denominator's power, so it's 1 over 2. That's less than, so that means that the horizontal asymptote is y equal to 0. So our asymptote, our horizontal asymptote is the x-axis. All right, then the vertical asymptote, we would need to factor. So this, the denominator would be, or let's go ahead, x plus 3 for the numerator, the denominator, the factors of 5 that give you -6. Let's see, should be -1 and -5. Yeah, because if you multiply them, you'll get +5. Okay, so if I set that denominator equal to 0, then my vertical asymptotes are going to be 1 and 5. So 1 and 5. 1, 2, 3, 4, 5. All right, so those are the asymptotes, and then the intercepts, right? So we need to find our x and y intercepts. So remember to find your y-intercept. You need to make x 0. So that would be y equal to 0 plus 3 over 0 minus 1 over 0 minus 5. If I want to use a factor form, which I really shouldn't have even used that one. But anyways, it's going to give us 3 over -1 times -5, which is really 3/5. So that y-intercept would be 0 3/5. So barely anywhere. So I'm going to place it right about there. All right, to find our x-intercepts, we're going to set y equal to 0, but really it's just the numerator, so x is going to equal, how about this? Okay, 0 equals x plus 3, so we know what we're talking about. So x must equal -3. So that x-intercept would be -3, 0. All right, so if we would continue with this sketch, I can go ahead and tell you based on the locations. Now, when you have like 3 different sections going on, like how we had in the last problem, and now how we have here, they're going to go in opposite directions. So you'll get something that looks like 2 L's and a hump, right? So on this first one, based on the x and y intercepts that we have, it looks like they're going to go something like that. The second one is just going to be some type of parabola, right? Because these are just sketches. And then the other one will go about there. Now we could have used other points to kind of help us verify for sure, but we don't have to on this problem because it says sketch. Now if it had said to graph, I would have suggested that you would have used values, for example, from -3 up to maybe 7. just to kind of see the shape. But we don't need to do that because it's just a sketch. So we're going to keep going. All right, so actually what we're going to do is this is it for regular Algebra 2. Example 5 is for pre-AP. So if you are in regular algebra and you want to just know, go ahead and continue, but actually we're done with Algebra 2. All right, let's keep going. All right, so example 5, it says you work at a pharmacy that mixes different concentrations of saline solutions for its customers. The pharmacy has a supply of two concentrations, 0.5% and 2%. Those are the types. Okay, so then it goes on to say the function below gives the concentration of saline solution after adding X millimeters of the 5% solution to 100 millimeters of the 2% saline solution. How many millimeters of the 5% solution must you add for, and it should have said for the combined solution to have a concentration of 0.9%. Okay, so here's the deal. First of all, we have to understand what this equation means, or this function really means, and how it's set up, because there will come a time where you will need to set up your own solution. So first of all, the 100 times 0.02, what that means is 2% of 100. So this is, let me use a different color, 2% of 100, right? And this on the other side is some unknown percent. That doesn't look like a percent. Some unknown percent of, no, sorry. Let me take that back. It's not an unknown percent. It is known. The percent is 5%. This is 5% of some unknown amount. That's what I was trying to say. We don't know how many millimeters we need. And so the denominator is going to be the amount of millimeters already there plus, again, that unknown amount. Okay? And in the end, we're trying to figure out how much we need for the new concentration to be 0.9%. So what we will do, and this is just a calculator problem, so that's why there's not a lot of space here. What we're going to do is in the calculator, so our first function will be this function that you see here. And the second function will be exactly what we're looking for, which is 0.0 or the 0.9%. But you have to change that to a decimal because the calculator isn't going to recognize the percent. So remember to change a decimal, a percent to a decimal. You move the decimal 2 places to the left. Well, this one already has a decimal, so we're going to move it 2 more places. So this is really going to be 0.009. Okay? Now, just like we've done in a previous rational problem, we set the two functions equal to one another. So really what we have is this function here equal to 0.009. So in order for us to only have to insert one function into the calculator, we're going to subtract 0.009 on both sides. And so what you will type into the calculator, and you've got to be very careful, y1 is going to be negative 0.009 plus, and then you have a lot of parentheses. So here we go. The first set of parentheses is for the entire one. It's almost like making the bracket, right? And then the second set of parentheses is actually your numerator. So you can say 100 times, and actually you need you need one more parenthesis just to be able to do this section here. So that's 100 times 0.02. Then you'll close that parentheses plus open parentheses for this one, x times 0.005. Close that parentheses, and then you'll close it again for the numerator. So close it again, and then you'll have the divided sign for the denominator, so the divided by 100 plus x and then you'll finally close it off to close off the brackets basically. And then you will graph that into your calculator. Now if you can't see everything, you're going to want to change your X min and X max. So the window that you may want to use for your X min should be 0. Your X max 500 should be good. Okay. And then what your graph is going to look like is something like that. And remember, we're wanting to know what that value is. And so you use the 0 function of your calculator if you remember that part. And so our answer will be that X is going to equal 275. So we're going to need 275 milliliters of 0.5% saline solution to get a combined total of 0.9% solution. I know that's a lot, but that's how you do it in the calculator. All right, so let's go ahead and do another problem just like this. All right, so again, it says you want to mix a 10%, and that shouldn't have been a period right there. So, you want to mix a 10% orange juice drink with 100% pure orange juice drink to make 40% orange juice drink. Says the function below gives the concentration Y of orange juice in the drink after you add X gallons of the 10% to 2 gallons of the pure. So this one here, 2 gallons of 100%, which we know is 1. And then the other one is an unknown gallon. So unknown gallons of 10%. And then the bottom is the gallons total. All right. So we want to know what we need to do, how much of the 10% do we need to add so that the combined percentage is 40%. So just like the last problem, that 40% we need to change to a decimal, which is really 0.4, right? So we're going to set this equal to 0.4, which means really we're going to subtract 0.4 on both sides. So in the calculator, you're going to have y1 equals negative 0.4 plus, and this is when we get all those parentheses again. So right, so there's one for the brackets, so that's parentheses, another set to talk about the numerator, and another set just to talk about that first part. So that's 2 times, we really didn't have to do that, we really could have just said 2, but I'll just keep going. 2 times 1, close that parentheses for that part, then say plus open parentheses x, open parentheses x, times 0.1, close parentheses for that operation, close parentheses for the numerator, and then divide it by 2 plus x, and then close parentheses to close off the brackets. Okay, once you type that all in, your x should equal 4, which would mean that you need 4 gallons of 10% juice to get a 40% juice mixture. All right, guys, we are done with this section. There was a lot to be covered. There was a lot to be talked about, but we are done with this section. So remember, if you need any questions, come see me for tutoring.